Yeah, good afternoon, everyone. Great to be here. Thank to Vinke, Johan, to the team for inviting us and being able to talk about something that is pretty far away from what probably most of you know and Laura. My name is Kristian. I run product management in the long-range business unit in Nordic Semiconductor, covering product for all our long-range radio technologies, including NR+ that I will talk about today. Yeah, Patrick was just on stage also from Nordic. We are a fabless semiconductor company, including to Bluetooth, where we are market leader today. We build wireless system on chips that have wireless connectivity for BLE, cellular, non-terrestrial, and Wi-Fi today, and other interesting things coming up in the future. So, NR+ and 5G. And why do I want to talk about this as a 5G technology? What is known as 5G is something that the International Telecommunication Union defined a few years back, and they put all the requirement for the next generation of wireless connectivity into the ITM 2020. Long, complex, hard specification. And then you have seen 5G technology rolling out in the cellular space because 3GPP, obviously, they jump on this and they implement that requirement into technical standards that's been deployed into cellular. But there is nothing in this standard that says that it has to be cellular. So that's what NR+ is. NR+ is a radio standard that basically complies with all the standardization in ITU for ITM 2020 as a non-cellular radio standard. And by non-cellular, I mean you don't connect to a cell tower, you don't need a subscription, you don't need a SIM card, but you build your own private network with something inherently as a 5G technology. So 5G, when we think about 5G, is really built around three major pillars. Mobile broadband that you have on your cell phone, massive machine type communication that Laura also is all about, putting a high number of devices out there. And this is where Nordic plays today, where we promote LTM and narrowband IoT and non-terrestrial, because you can then build something that you put globally with access to global infrastructure through the operators. But that's also where NR+ comes in, because NR+ is also defined and approved as a 5G technology for massive machine type communication. And for you, that basically means it's a radio standard that can support very high density of devices, up to 1 million per square kilometer, with interesting features such as massive amount of overlapping networks that work and interoperate, roaming support, and access to spectrum that is pretty wide many places in the world. But where NR+ really makes a difference is that in 5G, there's also part of that is called ultra-reliable, low-latency communication. And here we talk about wireless connectivity for really mission-critical things, where you need really milliseconds of latency, and you need 99.999 something % packet delivery on protocol level. And NR+ can do that. And what's really, really interesting about that, it opens up for possibilities to use standardized open radio technologies in use cases that up to now really haven't been able to use radios in any way. And NR+ is a really nice technology because it bridges this gap between pretty basic massive machine type communication standards like LoRa to very, very complex high-end 5G that is way too expensive for anyone really to use today in those use cases for low latency, to something that is in between and can do both. So let's dive a little bit deeper and look at what NR+ offers. So first talking about real-time communication, which is where NR+ really differences from many of the other things that you probably know about today. Down to 1 millisecond latency obviously give you opportunity to start building devices and go into markets that need latency way below what you typically do today. And this is something that is supported down on protocol level through to very complex technologies that also helps to provide very, very high reliability for the radio. So when I talk about high reliability, I would just say that ITU and those senior fellows that sat around those tables for weeks and weeks looking at those specifications, they have done their work, so I don't need to talk so much about OFDM and hybrid IRQ and signal durations and turbo coding and all that stuff. But these are things that this technology include on the physical level to ensure that you have a millisecond of latency, 99.99 something percent reliability on packet level, so that we see today already deployments in autonomous vehicles in factories and mission-critical systems that can use this radio instead of very much complex specific radios or wires. It's a very robust technology thanks to the physical layer. And the other great things about it is that it operates in a spectrum around 1.9 gigahertz, where DEC technologies can operate. So here in Europe, you have access to roughly 30 megahertz of spectrum at 1.9 gigahertz. The DEC as a technology is not bound to 1.9 gigahertz. It can also work at 900 megahertz all the way up to 4 gigahertz and higher. So it's also a technology that is very scalable. So in the future, if we see that, for example, 3.8 to 4.2 gigahertz spectrum here in Europe opens up for private networking, NR+ is a radio standard that's already approved and can be used in those places. The protocol and the standard itself has capabilities around self-organizing and self-healing, meaning that you can set up a network, the network will organize itself. Let's say you want to have a second gateway to build redundancy in your network. You throw that second gateway into the network, and the network will inherently reorganize and rebuild to allow for a separate gateway in the network. It has basically have built-in and standardized IPv6 support, which I think is really great because being in this market for 20 years, I see the long, slow trends that everyone really wants to have IP down to every device. And now you have something that have capacity and bandwidth and is built really from day one to run IP down to every device. You get pretty good range with this radio. In this building, I would say you will typically get up to a few hundred meters with milliseconds of latency and very high reliability. But then you can mesh to get whatever range you want and really build large networks, both inside and outside. Security-wise, this is really built with security in mind. You can build your independent operating network, your state-of-the-art security built into the stack itself. As I said, you are IPv6, so you can build all your networks based on standardized network connectivity. And obviously, when you have access to typically 2 to 3 megabit of bandwidth, 15 to 30 megahertz of spectrum, you have bandwidth to do memory updates and really do more data-intensive application that you can do with typically sub-gigahertz solutions today. So standard is great. There's no business without an ecosystem around it, and this is still early days. So let me also say a little bit on where we are on that. Nordic, we have really been a first mover. We helped define the standard. We built the first chipset for this, and we had the first physical layer and the first low-level stack to the standard. So what Nordic delivers today, we deliver basically a chipset with a modem or a radio domain, where we provide the physical layer and the lower layer of the standard, so you can access the radio and use it in a correct way. And then we have an API up to our software development kit that also Patrick talked about, which is the same also for NR+. And here you have access to a lot of middleware and stack, firmware updates, IP protocols, TLS, whatever you want to do. And here you also have access to third parties that have also implemented commercial stacks for NR+ today. So today you have commercial offering from Wirepass, typically for building massive mesh systems in metering and in citywide deployments. But you also have companies like Trondheim in Germany, who are building a stack for very low latency with very, very high security, already built and planned for CRA type of applications in, for example, automation in car factories in Germany. And you have Link in the US, who have built an NR+ solution that is used now by first responders in the US for professional audio and for headset. that they can meshing in audio and still also send data in the same network for first responders. If you look at hardware, the nRF9151, which is our cellular and NR+ module, is available today. It's a fully integrated module, so here you have a chipset that can do NR+, but it can also do cellular and non-terrestrial. It's a radio that supports from -20 dBm to 21 dBm output power. We integrated the PA and the crystals and everything and pre-certified. So basically, you don't have to build all that complex stuff yourself and try to certify it. And it has an integrated application MCU, and that means that you can also use a Cortex-M-based application with 1 megabyte of memory to deploy your own application inside the module. So here you have both the radio domain, where you can run connectivity, and the application domain. And then I want to talk a little bit about what are the markets for NR+. Where does it find its first use cases? Because this is a radio that is quite different from what typically many of you do today. And where are the leading use cases we see today for NR+ and a non-cellular, very capable, very robust 5G radio? In automation, people are looking for very high reliability, very, very low latency, very, very high security. So here we see NR+ now being used typically for automation, mission-critical systems, systems that need very high latency, and also see proof of concepts that are very interesting in autonomous vehicles in factories. Because you have a capacity of high bandwidth mixed with very, very low latency, so that you can send a lot of data and you can avoid collision because you have low latency communication between devices. In smart metering, we have really worked very closely with Wirepass as our lead partner for Stack, and there we really see NR+ being used in metering system where you want to deploy a massive amount of devices. In metering, you typically want very high reliability because the utilities can give very, very, very high level quality SLA to their end customers. We also want to have a high number of devices per gateway because that typically lower cost in the system, and here you can have thousands of devices per gateway. And because NR+ handles overlapping networks so efficiently, you can have multiple networks from multiple utilities in the same region, and they will still work and be independent of each other. And because you have fairly good bandwidth, you have low latency, and you can achieve 100 to 200 meters of range in this type of environment, the professional audio guys are obviously very interested in this technology. So some of the leading guys in professional audio, they're now building their next generation systems for venues like this and for professional audio with NR+. And as I mentioned, we have several companies now using NR+ for typically what I would say first responder, military, defense type applications. Because when you have low latency, pretty high bandwidth, not only can you build, let's say, first responder type radios with high quality, but you can actually do hopping. So you can mesh audio from one person to the next, 2 to 3 hops, with less than 30 millisecond latency. And because you can do audio and data with the same radio, you can prioritize meshing with low latency for audio, and then you can deprioritize data and mesh it with bigger mesh and longer latency for data. But you can use the same radio for audio and data. And the last thing we see is that some of the major guys in the building industry are now starting up. So for those of you who follow NR+ and knows a little bit, you have seen that Schneider, Legrand, and Siemens, they have joined the DECT Forum and the consortium for DECT technologies because they see this as really as a very, very promising for next generation technology for building automation. Why are they looking at NR+? First of all, for professional building, they need something with long range and high reliability. So 2.4 gigahertz doesn't make it in professional buildings. Secondly, they see that if they're going to scale, if IoT is going to scale in professional buildings, they need to have interoperability. They need to build solutions that are interoperable. And if they can build solutions that run IPv6, they can enable 2 things. You can build very standardized gateways because you can run IP from cloud all the way to all devices. But we're also there looking at building a layer for IPv6, which we can certify so that you can run some standardized application layer like Matter and KNX on top of NR+. And that enables this technology to, in the future, plug into big standardized ecosystem, not as an application technology, but as an application agnostic technology with stack that run up to IPv6 and with IPv6 so that you can put different type of application layers on top. Thank you.